In this tutorial, I am going to show you how to make a room transition camera in Godot, also known as the Zelda-Style camera, named after the classic Legend of Zelda. The room transition camera moves between rooms when the player gets close to the edges of the screen. This makes the game really interesting since the player doesn't know what is in the next room. There could be an enemy there, ready to kill you, or there could be useful items that will help you as you go through the level. Before we jump into how to actually do it, let's first talk about the idea. We have 4 directions the player can transition to: up, down, left, and right. To detect if a player is close to an edge of the screen, we will use an Area 2D node, which will detect a collision with the player. And since we have 4 directions, we will need 4 Area 2D nodes. Once the player hits one of those areas, the camera will smoothly move in the right direction. Okay, enough theory, let's start building the camera. The first thing you need to do is set up your world, player, and any other scenes you need in your game. The reason I develop the world and player first is so that I can test each step of the camera development. As you can see, I have already created a nice little prototype of a dungeon level and a player character scene. Once you have the basic framework for your game, you can come back and build the room transition camera. Let's start by creating a new scene, based on a Camera 2D node, and renaming the root node to RoomTransitionCamera. Create an Area 2D node and add a Collision Shape 2D node as its child. The Collision Shape 2D node will define the shape of the collider. In our case, this will be a simple rectangle. Next, duplicate the Area 2D node 4 times, 1 for each direction, and rename all nodes so that you don't get confused later on. For each of the Collision Shape 2D nodes, create a new shape resource with the Rectangle Shape 2D type. Now we need to define the shape size and location in the camera viewport. For the horizontal shapes, set the size to cover the entire width of the camera and the height to something small, like 16 pixels. For the vertical shapes, set the size to cover the height of the camera and the width to a small number of pixels. Then, move each one of the shapes to its appropriate position in the camera viewport. If the shapes are not aligning with the camera, simply change the grid snap options to suit your camera dimensions, as I'm doing here. The collision frame must be thin, to avoid endless camera transition loops. The collision won't work unless you define physics collision layers for the camera and the player. For your convenience, go to your project settings and name the physics layers you currently have in your game. Once that is done, you can go to each Area 2D node and assign the collision layers. The layer property is the layer of the Area 2D node, while the mask property is the layer you want to collide with. In my case, I set layer 2 to be the player, and layer 3 to be the camera. Don't forget to set the collision layers for the player as well. I have already defined them in my player scene. It is time to create the script that will contain all the camera's logic. Add a new script to the camera root node and give it a class name of RoomTransitionCamera. Now, we need to somehow get notified when the player collides with the edge detection shapes. The body entered signal, found under the Area 2D node, will be ideal for this purpose. Go to each one of the Area 2D nodes, and connect the body entered signal to a method in the script. As a result, you should have 4 different methods, each called when the corresponding shape collides with the player character. Okay, now we are going to implement the room transition logic. To keep track of the current room, define a vector2 variable that stores the coordinates of the current room the camera is pointing at. Next, we need to define how many pixels the camera moves when transitioning to the next room. If we move the camera by the viewport size, the player will be outside of the visible area. So the camera movement should be less than the viewport size, but not too low so it feels like the camera just moved. It should feel like a room transition, where most of the screen is changed. If you define the values properly, the player should overlap between rooms and exist in the current one as well as in the next one. This will depend on your character's size and might take some experimentation. Once the movement offsets are set, we need to implement a local method that will update the camera position based on the current room and the player's movement direction. Finally, call this method from each one of the signal callback methods with the appropriate direction value. But we are not done yet. There is a problem here. The code assumes that the camera is found at the center of the world scene, which is not always the case. If we move the camera and test it, you will notice that the transition is not working so well. To fix that, we need to tell the camera the player's offset from the center of the world scene. A nice way to do that is by making an exported node 2D variable, which represents the target node the camera should be aligned to. Later on, we will set the target to be the player node. Define a variable that stores the offset from the world's origin point. In the ready method, store the target's offset and align the camera position to it. And finally, in the update camera position method, add the offset from the origin every time the camera moves. This will make sure the camera is always centered on the room where the player is found. Go to your world scene and create a new instance of the RoomTransitionCamera. In the camera's inspector panel, you will see the target variable we defined in the script. Drag the player node from the scene tree into that property. The camera will now track the player node when moving between rooms. Let's test the game and see how it looks. Okay, so the camera transitions work, but there are 2 issues I see. 1. The rooms are not aligned with the camera. So every time I jump, I move between 2 rooms in a single jump, which is not good. And 2, the camera transitions instantly, and I want a nice smooth camera movement. But before I address those issues, let me just add some things to the world scene to make it a bit more interesting. Okay, I am now fixing the level, so that I don't get the room transition mid-jump. I reduced the brightness of the tile map and the player, and added lighting to create a dungeon-like atmosphere. Just adding a couple more things here. I also added the musical clefs the player must collect throughout the level. And now for the final touch. Smoothing the camera movement.